And then, okay. So chapter 1, we didn't even really have a class on because it is things like mean, median, and mode, right? This is the sample variance, the sample standard deviation. I'm not even reviewing how to calculate these things, right? It's the mean, it's the median, it's the sample variance, which is different than our population variance, right? And mean is different than the expected value. It's the same idea, but it's the difference between population and sample, right? Kind of back to our critical break between what is statistics and what is probability. I just like made some data and calculated all of these for it. I don't know why I did that, but the sample standard deviation is the square root of the variance, right? This is X bar. I think this is usually like X twiddle, but I don't think we learned that. This is S squared, and this is just S, right? For our notation for when we talk about those kind of things. And that's chapter 1, which I guess kind of sums up why I didn't really go through it. All right, so chapter 2 is all of our probability stuff, right? And hopefully working through these projects kind of has dug through this back part of your brain for all of this probability. There's not a reason for that, right? Kind of refresher as we're going through. Like terms, ideas of what's going on back in probability land, which we left a very long time ago, is the sample space, right? The sample space is all of the outcomes in your experiment. If your experiment is rolling a dice, it's 1 through 6. If your experiment is, ooh, I spelled experiment wrong. If your experiment is how long will it take me to get to HEB, then my sample space is the continuous line from 0 to infinity, right? It doesn't have to be discrete. It can be whatever it needs to be for that experiment. And it is any possible outcome, even if it's like no outcome at all, right? If the outcome is it doesn't happen, then that's still an outcome, right? That is different than the empty set, which is it like the whole experiment doesn't happen, and right. Your outcomes again are your results. All of your outcomes make up your sample space. The event is one or more outcomes in an experiment, right? That's a simple event or a complex event, right? Your event can be rolling a 1, your event can be rolling an even number, right? So you have to kind of combine those together. Again, I'm not going to go over like finding the probability of an even dice roll is the number of even dice roll outcomes over the total number of dice roll kind of thing. Let me go ahead and say I will pull up the chat and make sure I can see it on my screen. If you guys want to, if you have a question, if you have a thought, pop it in the chat and then I will see it. Side note. Let me get rid of that guy and now I can see that. Okay. So the complement, right, is everything else in the sample space, right? So the complement of a event is all of the other things that are in that sample space that aren't in that thing. The union, this cup symbol, is everything in one or both of those two things, right? So the union of A and B is everything in those. The intersection is everything that is in both of those events, right? Where I think I did have, let me just share this guy and this guy, right? Cool. So the union is this whole thing. I stole this off Google. The intersection is just this middle piece, right? So this is the stuff that's in A and B. This union is the things that are in A or B or A and B, right? So then when we go through and we look at our probabilities, how do these relate with each other? How do these talk to each other, right? Our kind of main additive rule here is that the sum of the two pieces minus the sum of the, or minus the intersections probability is the probability of the whole thing, right? That comes from when you add this and you add this, you get two copies of this guy, right? So you got to take it back out, and then you have the probability of the whole space. The probability of a space, plus the probability of its complement is 1, right? Which gives us that the probability of the complement is 1 minus the probability. This is also kind of showing at the same time that the probability of the entire sample space is 1, right? That's something you'll see pop back up in our PDFs, right? Your PDFs are all going to sum to 1, all of that good stuff. And then the idea of independence is that if your probabilities are, if you multiply the probabilities together, that is the probability of the intersection. If and only if this is true is when you have independence. Mutually exclusive, which I didn't put on here. I think it is in that. I'll share the that other document. We've got, yeah, mutually exclusive is when their intersection is nothing, right? If A is true, B can also not be true, right? They cannot be both A and B at the same time. That is our idea behind mutually exclusive. It's kind of, it's they can be independent, and like there's an interplay there. But we'll go back to this guy, right? So our multiplication rule is where we start to factor in our conditional probability, right? Conditional probability, refresher, is indicating what knowing B tells us about the probability of A, right? So this is our multiplication rule. This is this thing. It's the same thing, but the probability of the intersection is the probability of A given B times the probability of B, right? It is also the probability of B given A times the probability of A, right? You can do both of those either way. And the way you compute your conditional probability is the probability of the intersection over the probability of B, right? The second one, the thing you're conditioning on. That's what goes in the bottom. So, example of how you would use this, right? We have two events. B is that the student is checking out a book. D is that they check out a DVD. And we have our three probabilities. What is the probability of B and D? Note that I am making you translate from and to intersection or union. I'm going to turn your faces back on and wait until one of you sits here and scribbles out the answer.
Point 2, right?
Come again?
Is it 0.2?
How'd you get that?
So probability of B and D is equal to the probability D given B into probability of B.
Yep. Right. So you're taking, you're using this guy, right? Because that's and, is our intersect. And it is the probability of D given B times the probability of B, right? 0.5 times 0.4 is 0.2. B or D, I can't scroll up that high and still give you the things, can I? Right, for that you need what we just found, 0.2. So you have 0.4 plus 0.3 minus 0.2 is and, right?